Alright, for this question, it asks you to find the minimum distance from the point 1, 2, 3 to the plane of x minus y plus z equal to 3. So they give you a hint to minimize the computations by squaring up the formula. So if you have the distance square, and you would get x minus x naught square plus y minus y naught square plus z minus z naught square. Alright, so you can plug in the numbers, but before you do, you have x, y, and z, but your z will be 3 minus x plus y because I'm solving for z from the original plane equations right here they're given. So now I'm gonna plug in the numbers for the knots. X minus 1 square plus y minus 2 square plus z, which is right here that we just solved, 3 minus x plus y. We're trying to only have two variables, not three, because the computation will be really complicated. So now you can go ahead and simplify these equations for the z. So the 3's cancel out, so you would have y minus x square. So you can find the partial respect to x and the partial respect to y from this from the original equation right here that we just got. So your partial respect to x will be 2x minus 1 minus 2 y minus x. Don't forget the chain rule inside for the negative x. Okay, do the same thing for y. 2 y minus 2 plus 2 x y minus x. Okay, so now you can set your partial of x and partial of y equal to 0 to find any critical points. So if you set 2x minus 1 minus 2 y minus x equal to 0, 2 y minus 2 plus 2 y minus x equal to 0, you can now distribute and simplify it. So you would get 2x minus 2 minus 2y plus 2x equal to 0, 2y minus 4 plus 2y minus 2x equal to 0, and then simplify it. So you would get 4x minus 2y equal to 2, and negative 2x plus 4y equal to 0. Now you can plug this into your calculator and use the matrix to find it, or you can solve it by elimination or substitution, whichever the method you're more comfortable with. After you solve for x and y, you would get x equal to 4 over 3. Y will be 5 over 3. So after you get these two values, you can plug it back into this equation right here for z, so we can find a z. So z will be 3 minus x, which is 4 over 3, plus 5 over 3. Your z will be 10 over 3. Alright, now you have x, y, and z. You can go back to the original distance formula equations. So the distance square will be x, which is 4 over 3 minus 1 square plus y minus 2, oops, not y, 5 over 3, 5 over 3 minus 2 square plus y minus x. I'm using this equation right here, which is 5 over 3 minus 4 over 3 square. So after you get this answers right here, you can go ahead and do the square root to find the actual distance. So you can do the square root. You will get root 3 over 3. So this is your actual answer. So this is your minimum distance from point 1, 2, 3 to the plane x minus y plus z equal 3.